Hey everybody, today I'm going to talk about music theory, because why not? So, where's my pen? Let's go. So, music theory. I'm going to tell you guys all I know about music theory. Well, not everything, but I guess something. So, what do we know about music theory? So, in general, everything in music, for the most part, maybe it's like changing nowadays, but we found out. So, what is music? I mean, let me write that down. So, what is music? Music is basically, I mean, you can count percussion as well, but it's pretty much pitches, pitched noise, and then with rhythm. I think that's a pretty good way of putting it, right? Pitched noise with rhythm. So, when somebody's singing, they're making pitches and they're following a certain rhythm so that out comes a song, right? So, so I guess what kind of pitches are there? I guess that's a good question. So how do we make noise with different pitches, right? What kind of pitches? So I guess what happened is like I don't know the science behind the waves and whatever how the sound works, but we pretty much figured out that. Um, so let's just take a pitch here and let's call it C. So we figured out that I mean if we we can basically like pitches like they like repeat. I don't know if it makes sense. So here you have a C. We call this pitch a C, so it's a certain note. So like the like that would be a C. I don't know if that's actually C. I think it's might be wrong or it might be close or whatever. But that's a C. And then we can make a noise of a higher pitch and have that also be a C but higher. So basically, you take any pitch and you can find the same pitch, but it sounds higher. And how do you know it's the same pitch? That's also a good question. I don't know the answer to that. Then we and then you can do it again. C, but even higher. And then you can find another one. You can find infinitely many of these. However, obviously the human hearing is limited. So obviously there's going to be a limited number of C's of pitches that are that we see them as the same. And so when you hear both these pitches at the same time, they sound like so there's a so it's called an interval, right? There's a distance between these pitches in your ear, so you can hear both pitches, and there's an interval here, and the interval. I mean, it makes sense why it would be, but it's the same. Like I don't know how it works in terms of science, but the interval between the pitches is the same. I think in your ear, just the way it sounds like, whatever, the way it works on the piano, everything probably lines up. Like the interval is the same. So the difference in the pitches. I don't know. None of this. I never bothered to look up the science behind this, but here we go. C, C but higher, C but even higher, and then we go on, and then we have lower C's on this side as well. So lower C's this way. So so let's find some more pitches. So we found a C and then we found a C but higher. So there's a lot of pitches in here. And how many pitches? Well, a good way to subdivide. So you can always find an infinite number of pitches because this is a continuous. Pitches are continuous. You can find C and you go a little bit up here and it'll be C, but a little bit, a little bit sharp. So it'll just have just a little bit of a higher pitch. Um, but basically, what people found, I guess, um, by experimentation in the medieval period or whenever people started singing, I don't know, is that it's probably a good idea to divide these pitches into 13 equal steps. So there's a C, and then the pitch that comes after C is C sharp, and then D, and then D sharp, and then E, and then F, and then F sharp, and then G, and then G sharp, and then A, and then A sharp, and then B, and then C again, but higher. So the C sharp is higher than C, the D is higher than the C sharp, etc. And the distance between these is always the same. So these are equidistant pitches. So why do we divide them into 13? Why? Because we found that the interval between some of these pitches is sounds really good, and or it has, it just sounds good to our ear, or it sounds organized, or it sounds correct in some way. And we found out that we needed to divide our pitches into 13 to make sure that we could we could always basically, let me give you an example. So one interval that sounds good is we play one pitch here, and then we play the other pitch E. So this is like, it sounds happy. So now how many what's the interval between the C and the E? So 1, 2, 3, 4. So there are, between these, the distance is 4 pitches. So now we should be able to pretty much replicate the sound. We can replicate, so since all of this is equally what this sounds like this. So if instead we want to hear the same thing, but we want the bottom note to be D, we can do that. And so then we start on the D, we go 1, 2, 3, 4, and we end it with the F sharp. And so this is going to sound, since the pitches are equidistant, this thing is going to sound exactly the same. Sounds exactly the same, but it's going to start at D. So here's what we did. So we let me just summarize. So we found a pitch, then we found that we can hear the pitch at a higher, like the pitch repeats in some sense according to our ear on a higher note, and then we divided this distance between the repetitions into 13 equal steps. We found out that looking at the distance between some of the pitches formed by the steps sounds good, and because equidistant, we can use the same distance starting at any of the notes. So how do we form music? I guess we form music by, we form more complex music by playing multiple pitches at the same time, right? So if we play both these at the same time, it sounds happy. And in fact, so I guess so here's our C. So at the same time, we sing. So here's our previous distance to the E, and then we're going to add in a G on top of this. And the G is only 3 half steps. And this is 4 half steps. And this sounds happy. But if we instead do the D sharp here, and then G, so what we've done is now this is 4 half steps, and this is 3 half steps. This sounds sad. Why? I don't know. So the question is, why do we not have an E sharp? Because then we wouldn't have 13 equal steps. Same thing for B sharp. And obviously, you can either say A sharp here, or you can say B flat. So what does sharp mean? Sharp means 1 half step. So A sharp is 1 half step to the right of A. And what does B flat mean? It means 1 half step left of B. So A sharp and B flat are the same thing. They're just written differently. So you can rewrite each of these, or you can reference the same pitch by just naming as a flat. So instead of C sharp, you can say D flat. You can say E flat here, and then sometimes it's convenient to do that, just to make the music clearer to read. So I guess the next point is, so we formed some happy sounds and some sad sounds, and now we want to figure out, so a chord is I guess several pitches played at once, which is what we just made. Played at once. So we made a happy chord here, and we made a sad chord here. So is there a way to figure out, so I guess the question is, what chords sound good together? Or like, yeah, what chords can you put in a reasonable, like one after the other, and it makes sense to ear? I guess so here's what we're gonna do. Here we have all of our pitches, and it starts at the bottom, and then it gets to C and it repeats. So what we're gonna do is we're gonna select only some of these notes. So I'm gonna select the C, then I'm gonna select the D, and then the E, and then the F, and then the G, and then the A, and then the B, and then here the C repeats again. So what have we left out? We left out the C sharp, the D sharp, the F sharp, the G sharp, the A sharp. These are the ones that we have left out, and only kept these ones. Notice that the E and F are only one distance apart, and the B and C are only one pitch apart, but all the other ones are 2 pitches apart, or 2 pitches to the next one. So we have chosen a subset of the pitches, of the 13 pitches, and now we're going to construct chords. How are we going to construct chords? We're going to pick one of these notes, so C, and then we're going to go up two spaces according to the ones we picked. We're not going to go to D. We're going to skip the D, and we're going to go to E, and then we're going to go to 2 up from the E, so G. So this is our happy chord that we came up with. Happy. And now we're going to do this again, but for all the other notes. So D, F, A, and this one is, I mean, I know it's sad, you can calculate it out, or like the one that we mentioned here, where the distance between the first note and the second is 3 half steps, and the distance between the second and the third note is 4 half steps. I'm just gonna write sad. So then we can keep going. B is also sad. Then F, A, C. This is happy. Then G, B, D. This is happy. And then A, C, E. This is sad. And then B, D, F. This one is kind of, I'll just write scary. Why? This is not quite sad. This is 3 half steps here and then 3 half steps here. So it doesn't fit into either one of our things. And the distances between pitches in a chord doesn't have to be 3 or 4 half steps. It can be any you want, but these are the chords that we're building so far. So, okay, so we built 7 chords, right? 1, 2, 3, 4, 5, 6, 7. Yeah. So, I mean, how do I put this, right? So what is music? Music is, like I said, pitch noise with rhythm. So what we're going to do, we're going to maybe sing this chord for a little bit. Let's just say for 2 seconds. So step 1, we're going to sing this chord for 2 seconds. Then we're going to sing this chord for 2 seconds. Then we're going to sing this chord for 2 seconds. And then finally, we're going to end off and sing this chord for 2 seconds. And you find out that this is, so we have the first, we have C, G, and then we go to F, A, C. Okay, we get it, right? Dot, dot, dot. So this sounds pretty good. This sounds pretty good. Yeah, especially, I will say, so when you construct these chords, the C that I picked in the beginning, well, I picked the notes like I pick them because I know the right notes to pick. So if you, again, you can repeat the same pattern here by starting at any note, not C. So you could start at D instead, or at E or F. But if you follow the same, algorithm for picking the right notes, and then you construct the chords in the same way, you should end up with the 7 chords, and they will sound exactly the same. Why? Because all we have done is move our starting point from C to like E or F or wherever you started. So I'm gonna call this chord the 1, and then I'm gonna call this chord the 2, and then this chord the 3, and this chord the 4, and this chord the 5, and this chord the 6, and this chord the 7. Why? Because this one starts on the first note, second, third, fourth, fifth, sixth, and why is this one capitalized and this one like lowercase Roman numerals? Because these are the ones that are capitalized are happy, and the ones that are non-capitalized are sad or scary. So hopefully that makes sense. So basically, the chord progression that I've written instead of using the notes is basically I started with the first chord, then I went to the fourth chord for 2 seconds, I went to the fifth chord, and then I went back to the first chord. And this is a pretty common chord progression, and it sounds good to our ear. So let's see, where should I go from here? Pitch noise, 13 equal steps. Yeah, basically, so you can write music in whichever you want. You don't have to even use these pitches if you want. You can make whatever. You can take out a saxophone and play whatever pitches you want out of there, and it'll sound bad. But organizing the pitches in terms of these, subdividing these intervals into 13 equal spaces and constructing chords from these, this is how you make structured music, or the music that has been created over the last 500 years, just by making instruments that can play these individual pitches and then making them play pitches at the same time to create chords, right? So like on a piano, you have, you know what a piano looks like there. 4, 5, 6, 7. So there, and then here, and then here, and then here. So this is a C. This is a C sharp. So the black notes are the sharps. This is a D, E, F, G, A, B, and then these are the sharps. So D sharp, F sharp, the black notes. G sharp, and then A sharp, right? What else did I want to say? B sad. Right. Oh yeah, this is what I wanted to say. So basically, so when you construct these chords, basically you figured out. You can play whatever chords you want. You can play a C E G chord, and instead of using any of these chords immediately after, you can follow. This also sounds good. You can follow it up with this chord: A flat, C, E flat, and that's crazy. Or then suddenly you can play right after it. You can play a B flat, D F, and then go back to the C E G. Like the uh, the possibilities are limitless. But over the past 500 years, you basically what you do is you pick a key. Pick a key. So this is like, so what does this mean? So this is your pick a starting note, which is C. So now from now on, your song is going to be, from now on, your song is in C. What does that mean? That means that recommended recommended you use those chords. Pretty much like these ones, the ones that you figured out. So now if you instead you pick F sharp, then you're gonna use the same chords. I mean, you're not gonna use exactly the same chords. You're gonna come up with the exact same chords starting from F sharp, and you're gonna use those chords mostly. So yeah, and so then what you're gonna do to write your piece of music, you're gonna probably like you're gonna have a melody, and the melody is gonna have like it's gonna just play pitches, like somebody's gonna sing, and then you're gonna have, and then in the background you're gonna have chords. Chords like the ones that we've come up with, like the ones we have come up with. And usually also your melody is only gonna play, only going to play the notes that we picked out. You know, we only picked out some of the notes. So let me show you which ones we picked out again. We picked out this with these notes starting at C, and the notes that we picked out, they form a scale. So like which notes we picked out. Yeah, so generally that's how you write a piece of music. You pick a key, you create the chords, you create a melody over the chords. So for example, if you play if you're on the F chord, so if you're on this chord, which is FAC, notes that sound good with FAC are generally like your melody. You want it to, while this chord is going on, you want it to be melody around FAC as well. So it's gonna, your melody is kind of walk around the same notes, and it's gonna sound good. For example, if instead you play a B here, which is probably if your melody sings a B, this is probably gonna not sound so good. Usually, not sound great. Why? Because the distance between the B and some of these notes, for example, the C, this is like an awkward pitch distance interval, and it's gonna sound awkward, which might be what you're going for. There's no wrong or right answer, but it's not gonna sound natural, which is fine. So hopefully that's a good introduction on music theory. Hope you enjoyed. See you next time.